The history of the Earth's climate is very difficult to decipher. The evidence for it is indirect, and the further in the past we search, the more difficult it is to find that evidence. It is important for us to know about the Earth's past climate because it gives us clues about how the climate might change in the future, and this will have a direct effect upon our lives. So, what is the evidence for temperature in the past? One source of information comes from counting the number of atoms which have more or fewer neutrons than average atoms. These are called isotopes. For example, most oxygen atoms have 8 neutrons, but a few have 9 or even 10. The ratios of these different oxygen isotopes tells us the temperature when fossil rocks were formed millions of years ago. Another source of evidence comes from measurements of the gases trapped in bubbles of air frozen into ice thousands of years ago. An ice core is a cylinder cut out of the ice. This photo shows the bubbles of air which are trapped when the ice freezes. These bubbles contain samples of the ancient atmosphere. From these, it is possible to measure directly the past concentration of greenhouse gases in that ancient atmosphere, and these gases therefore allow us to work out the historic temperature. This graph shows a reconstruction of the average global temperature during the past 500 million years or so. It is based upon the ratios of the isotopes of oxygen atoms in fossil rocks. The diagram shows that there have been intervals of tens of millions of years when the Earth was very cold. These are called glaciations or ice ages. At other times, the Earth has been very warm and there was no ice anywhere on the Earth. The Earth has been in an ice age during the past 2.5 million years. In the next diagram, we will focus on the last 500,000 years, approximately the size of the little red box in the right-hand corner. This graph is derived from ice cores taken at Vostok in Antarctica. The graph shows only the last 500,000 years. It shows that an ice age consists of cold periods called glacials. During a glacial, ice covers the north and south poles, and glaciers descend from the tops of mountains and spread out over the surrounding land. Today, about 10% of the world is covered by ice, but during a glacial, 30% or more can be covered. The graph also shows that an ice age is not cold all the time. The glacial periods are interspersed with warmer periods called interglacials. We are in an interglacial now. Why do these changes occur from glacial to interglacial? The cycles of glacial and interglacial periods during an ice age are mainly controlled by the Milankovitch cycles, which we have already talked about. Note that the change from a warm interglacial period to a glacial period happens slowly, whereas the glacial periods end suddenly. This is because once warming starts, there are several feedback processes which tend to accelerate the change. We are now in an interglacial shown by the red box. We will examine it more closely in the next diagram.